Welcome to Laws of Indices Level 2. Pause the video now, try the 5 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're simplifying 10y to the power of 6 over 5y to the power of 3 multiplied by 7y to the power of 4. Starting with the fraction on the left-hand side, we can see that we're dividing indices here. So we're going to start by using this law, which tells us that when we divide indices, we subtract the powers. So 10y to the power of 6 divided by 5y to the power of 3 becomes 10 divided by 5, which is 2, and then y to the power of 6 divided by y to the power of 3 becomes y to the power of 6 minus 3. And this is still multiplied by 7y to the power of 4. Now simplifying 6 minus 3, we have 2y to the power of 3 multiplied by 7y to the power of 4. Since we're now multiplying indices together, we're going to use this law, which tells us that we need to add the powers. So starting with 2 times 7, this gives us 14, and then using our law, y to the power of 3 multiplied by y to the power of 4 is y to the power of 3 plus 4. And since 3 plus 4 is 7, our final answer for problem 1 is 14y to the power of 7. In problem 2, we're evaluating 3 to the power of minus 3. This means that we need to find its value. Now, since we have a negative power here, we're going to use this law, which allows us to rewrite 3 to the power of minus 3 as 1 over 3 to the power of 3. And since 3 to the power of 3 is 27, our final answer is 1 over 27. In problem 3, we're simplifying 4x to the power of 6, z to the power of 2, all raised to the power of 3. Since we're raising powers to powers here, we're going to use this law, which tells us that when we raise a power to another power, we multiply the two powers together. Before we start, we need to write 4 as 4 to the power of 1. And now we've done that, we can start multiplying our powers together. So starting with 1 times 3, we have 3, so this becomes 4 to the power of 3. Next we have 6 times 3, which is 18, so we have x to the power of 18. And finally 2 times 3, which is 6, so we have z to the power of 6. Simplifying 4 to the power of 3, which is 4 times 4 times 4, we have 64, x to the power of 18, z to the power of 6. And that's our final answer for problem 3. In problem 4, we're evaluating 1 over 2 to the power of 5. This means we need to find its value. To start off, we're going to rewrite 1 over 2 as 1 to the power of 1 over 2 to the power of 1. And the reason it's important to do this is that we can now see that this problem involves raising powers to other powers. And because of that, we can use this law, which tells us that when you raise a power to another power, you multiply the two powers together. So starting with the numerator, we're going to multiply 1 by 5, which is 5. So we have 1 to the power of 5. And similarly with the denominator, we're going to multiply 1 by 5 here, and that also gives us a power of 5. Now 1 to the power of 5 is 1. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, which is 32. So our final answer to problem 4 is 1 over 32. In problem 5, we're told that g to the power of 8 multiplied by g to the power of 3, all divided by g to the power of n, is equal to g to the power of 4. And we need to find the value of n. Looking at the left-hand side of the equation and at the numerator, we can see that we're multiplying indices together. So to do this, we're going to use this law, which tells us that we need to add the powers when we multiply indices together. So g to the power of 8 multiplied by g to the power of 3 becomes g to the power of 8 plus 3. Our denominator is still g to the power of n, and it's still equal to g to the power of 4. Now if we simplify the numerator, 8 plus 3 is 11. So we have g to the power of 11 over g to the power of n is equal to g to the power of 4. Now the fraction on the left-hand side of this equation tells us that we're dividing indices. And when we divide indices, we use this law, which tells us that we have to subtract their powers. So g to the power of 11 divided by g to the power of n becomes g to the power of 11 minus n, and that's equal to g to the power of 4. Now since the left and the right are equal to each other, and they both have the same base, which is g, we can say that their powers must also be equal to each other. So 11 minus n must be equal to 4. We can solve this by inspection, by saying what do we have to subtract from 11 to give us 4. We can also solve this more formally by subtracting 11 from both sides, leaving minus n is equal to 4 minus 11, which is minus 7. And if minus n is equal to minus 7, then n must be equal to 7. And that's the final answer for problem 5.